So today I'm going to be going over ANOVA. I'm really excited about this because it has a lot of really practical implications. ANOVA is typically used in order to analyze very simple experiments. We tend to, when I worked at Bayer, we tend to use something for more complex data, but especially in, say, clinical trials or smaller experiments where you don't have a ton of control variables, ANOVA will be used pretty much every time. So this will be really useful to you all who are interested in experimental design. You guys are interested, I can actually do a session on experimental design itself and how you would set up experiments, both statistically and the just setting the experiments up themselves. But just to recap, I wanted to give you guys the definition of variance. So going forward, given that you guys have had more experience with the different data techniques, so far I've tried to not use very many formulas so that you guys can easily understand with common language what the formulas do. I'm going to, going forward, unless they're very complex, try to use the formulas, because when you look at any statistics or data science book, they're going to be very heavy on the formulas. So now that you have a little bit of a base, I'm going to start using these formulas instead of putting things out in words. So variance. This is very similar to the standard deviation, which we learned about. I think I've gone over variance before, but it's very important concept for today for ANOVA. So when we're looking at this, this character right here always means sum of. And then these subscripts, we're saying in this case that we're starting at 1 and going up to the number of observations that are in our data set. So that's what this N is here. So in order to calculate variance, we take all the data points in our data set, and then we subtract the mean from your entire data set, and we square those values. We do this part for every value in our data set or the group of interest, and then we sum all those values. Then that result, this total sum, will be divided by the number of data points in our data set. So I'm going to try to be using these just so when you go into a statistics book, you won't be totally blown away and confused by the symbology here. Are there any questions about that and this formula in particular? I want to make sure that that's clear. Okay, I'll move on. So this is used a little differently in ANOVA, but it's all based on variance. ANOVA stands for analysis of variance. So in general, when we're doing ANOVA, we're looking at the variance between independent variables and dependent variables. So when do we use OneWay ANOVA? I talked a little bit about this already. So the ANOVA very simply compares the means between different levels of one independent variable to a dependent variable. So that'll make more sense when I go over a couple of examples. When I say the different levels of an independent variable, what I mean is, say you have a continuous variable, that would be your dependent variable, what you're trying to understand. And then you're looking at the relationship at dependent variable, and then a categorical variable that can have two recognize this to a t-test. So when we went over the t-test, it did the exact same thing, except when you were looking at that categorical variable and the relationship with the dependent variable, there could only be two levels or two groups that you were looking at. In this case, you can have more than two levels. This is specifically a one-way ANOVA. I'm going to go over a two-way ANOVA towards the end of class. But so we're explaining our continuous variable with a categorical variable that can have more than one level. That'll make more sense in just a minute. So it looks at the relationships between that categorical variable, the levels of that, and our dependent variable, looking at the means, the difference in means between those levels. And then say you get a significant result, so your p-value is below 0.05. Say you get that, and we'll have an example of that when I go step by step. But that means that at least 2 levels of that categorical variable are significantly different from one another. Say you have 4 levels. When you get a significant result, that means that any 2 levels in that a categorical variable are related to one another significantly. So that is a little different than anything you'll really ever see. It's pretty particular to ANOVA. So you don't know by running an ANOVA which levels are different from one another. You actually have to run something called a post hoc test in order to see the relationship between those levels. And then that'll tell you which levels are actually different from one another. I'll come back to this in just a minute after I show you some examples, and then I'll try to explain it again based on those examples. So one thing you're hearing me say groups, independent variables, and levels. What are the difference between those? So when we're looking at our independent variable, so that will be a categorical variable, as I said. An example here would be self-reported stress levels and say different income groups. So the stress levels themselves, the self-reported stress levels, would be your independent variable. So or in this case, sorry, your dependent variable, that's what you're trying to explain. So I'll say that again because I misspoke. So your self-reported stress levels in different income groups, that's what you're doing your analysis. That dependent variable, what you're trying to explain are the stress levels. So some type of continuous variable that the independent variable, we want to know the relationship between income and those stress levels. So in this case, income would be it would be categorized as high, medium, or low in this particular example. So we would look at the mean of high stress levels, the mean of medium stress, the mean of high income, the mean of median income, and the mean of low income when looking at those particular stress levels. So notice that our independent or predictor variable is a categorical variable, and our dependent variable is numeric. A couple more examples, and then I'll go back and try to explain once you have those examples. So OneWay ANOVA example scenarios, I have down here a link that I got these examples from. These were not produced by myself. So OneWay ANOVA examples. So as I said, they're often used to analyze experiments. This is by far the most common thing that you will see them used for. So the first example that this website gave is that a group of psychiatric patients are trying 3 different therapies: counseling, medication, and biofeedback. You want to see if one therapy is better than the others. So in this case, they would have some dependent variable that measured improvement in a psychiatric psychiatric outcome, and then it would compare the counseling, the medication, and the biofeedback. The second example is a manufacturer has 2 different processes to make light bulbs. They want to know if one process is better than the other. So again, you would have say light bulbs that didn't work at or the brightness level would be a great way to say. So if you look at the brightness level as a continuous variable, you would want to see if those one process had more brightness than the other process. So that's a second example. The third example would be students from different colleges taking the same exam. You will want to see if one college outperforms the other. So our independent variable would be the college, levels would be college 1, and the second level would be college 2. And say we were looking at SAT scores, that could then be our dependent variable, given that it's continuous. So I'm going to recap again, go back to this slide, just to pull that all together now that you've seen practical examples of what an ANOVA does and why you would use it. So again, We have our independent variable. We are looking at the relationship between that independent variable and our dependent variable. The independent variable will be categorical. It will have multiple levels. It can be 2+ levels, so anything 2 or above could be included. And we would be looking at that independent variable and its relationship with that dependent variable, specifically the means in that independent variable. So if we have more than one level, for instance, as I said, income level, high, medium, and low, and its effects on stress levels, we would find the mean stress level in high income, the mean stress level in the middle income, and mean stress level in the low income, and then see if the stress levels differ by those three groups. And the ANOVA will not actually tell you which levels are different from one another, so you have to run an additional test to tell you those details. And I will show you how to do this in practice. So now that I brought it all together, showed you examples, try to explain it at a high level. Are there any questions about the high level explanation that I